Lesson 11.11 is called the correlation coefficient. This is going to be represented by the letter R. So a correlation coefficient is a number you could get on your calculator when you put in your data set and then you get a line of best fit. We didn't make that feature pull up, but this lesson will actually tell you what the R values are, so we don't need to know it. But there's different types of correlation that I wanted to show you. So this one is called perfect positive correlation because the points all line up perfectly. They're all really close together, making a perfect straight line that has positive slope. So that's the highest correlation you can get, which is 1. You could have a perfect negative correlation, so where the points are making a straight line going down over time. That would be -1. But still think about the absolute value of that is 1. It's just like 100% correlation, but it's in the negative direction. And then we have strong correlations, either positive or negative. That's going to be a number that's between 0.5 and 1. So if you had something that had an R value of 0.8, that means that it's not perfect, but it's pretty strong. And then same thing here, I realized I wrote the numbers in the wrong way, between -1 and -0.5, so like -0.6. It's not as strong as -1, it's not perfect, but it's still pretty strong. Then we have weak correlations. You can tell this is almost so random, it's hard to tell that there is really still kind of a line of best fit here. But the points are so scattered, it would be a really small number, really close to 0, like 0.1 or 0.2. And a negative, again I wrote the numbers wrong, would be between -0.5 and 0, getting really close to 0, like -0.2 or -0.1. So between 0 and 1 is kind of what you're thinking of. Okay, there's another page I want to show you where I thought maybe this would help, kind of a sliding scale here. This is our perfect positive of 1. This is our perfect negative of -1. 0 means there's no correlation, and then if you're more than 1/2, that's strong. If you're less than -0.5, you're strong negative, and then you're weak if you're between 0 and the halves. And something I want to point out, remember a teacher in college telling me this, correlation does not equal causation, meaning just because some data correlates, it doesn't cause it. For instance, if more cars are sold during the summer, it doesn't mean that the temperature causes more cars to be sold, but there's a relation, maybe because it's teachers that are on vacation, or people are more ready to get outside in the summer. Who knows? But it doesn't mean one variable actually causes something else, but there's a pattern or trend between them. So here's what your problems will look like. Which of the following regressions represent the strongest positive linear relationship between x and y? So you're looking at the R value only. That's the only thing you care about. And you want to get strongest positive, which is as close to 1 as you can get. So look at your R's. We know it's not going to be negative R's, so it's not that and it's not that. It would be regression 2 because 0.8 is bigger than 0.3. Number 2 says, which of the following regressions represents the strongest negative linear regression? So again, looking at the R value, strongest negative would be the closest to -1. So it's not going to be any positive correlations. And then this is -0.1, where this is -0.7. This one's going to be the closest to -1. And number 3 says, which of the following regressions represents the weakest linear relationship between x and y? This could be positive or negative. You want to kind of think about the absolute value of these, which all makes them positive so you can relate them. Which one is just the smallest decimal? There's a 7, 8, 2, or 6. 2 is the smallest. So even though it's negative, it's still the weakest, where the points would be the most scattered out. And not as tight together as you're getting closer and closer to either 1 or -1.